Right. That class is for chapter 2.1, circuit elements. Um, we are done on the chapter 1, and also I have unloading for the practical, the questions from the homework in the record video. For today, from this video, we're going to cover for chapter 2.1, circuit elements. Oops, sorry. All right, that was for chapter 2. After chapter 3, we're going to test one. All right, so they want to cover for 2.1 to 2.5. The book is 11th editions for electrical circuit, Nelson. Okay. So from this chapter, we wanted to learn about the symbol and behavior following this really basic idea of circuit elements, independent voltage and current sources, dependent voltage and current sources, and register. Especially from register, we're gonna extract of the Ohm's law and also Kirchhoff's voltage law and current law, which can be used using these laws to analyze the simple circuit. And from this, the circuit, we'll try to how can we calculate power for each element in a simple circuit, the basic idea of simple circuit. And we try to determine whether or not the power balance for the whole the circuits. Okay. All right. So that was for section 2.1, the sum of them. So this is what we wanted to do. This is the homework too. I'm going to unloading the solution in the Blackboard. You can see that future. Okay, so voltage and current sources. The first over, I wanted to make it clear, in the circuit, there are 5 either basic circuit elements. Okay, so well, there's a lot of the elements or components which consist of the circuit. However, for my class, for the circuit analysis number 1 in this semester, we have only the 6 and 5, the components here. The one is the resistor. It's R. It's a symbol. A capacitor, the charge, plate of the charge, that's line. It's the inductor L. This is the battery, the DC voltage. This is also voltage sources as well. And this is current sources. Okay, it's the arrow. You're gonna learn for the future, but this is plus and minus. Okay, so the capacitor also long line, short line. Long line is plus, short line is minus. All right. Um, they have the 2 different sources, but the ideal voltage source and current sources. The ideal voltage sources is a circuit element that maintain prescribed voltage across terminal regardless current flowing those terminal. Okay, so even though the current is increased or decreased value, but the voltage is the same, the constant. So that was the ideal voltage sources. How about the ideal current sources? That is the one of the circuit elements that maintain the current, prescribe that maintain the current through its the terminal regardless voltage across the terminal. So that is the one of the ideal voltage sources description. We have all is the voltage drop across the ideal voltage sources. There is no formula because we can use calculate the current through the sources. Um, so the any value, the I, that was the same constant V sub S. Okay. So how about the current? The current is like saying the voltage value that was the same one value of the current V sub S. Keep in mind when we draw this one, we assume that that was the plus, that was minus, and the source voltage right there. Okay. Um, so in the previous 2 slides, we're going to learn about the dependent sources, but from these slides, we're going to learn about independent sources, independent. Okay, so independent, dependent, it depends on the source type. So independent sources, stability, voltage, and current, a circuit without line voltage on voltage and or current, the elsewhere on the circuit. The value, the V and I supply is specified the value independent source alone. So that was the specific, the constant value for the each independent source. However, the dependent sources, that was voltage or current, its value depends on the value of voltage current as well in the circuit. So it means you cannot specify, okay? You cannot specify the value, dependent sources, unless you know the value of voltage and current on which it depends. Okay? All right, so we'll try to figure out, let's see dependent voltage source first. So the dependent voltage sources, they have 2 types. One is VCVS, the other one is CCVS. So VCVS is voltage control voltage sources. V sub S is supply voltage, definitely. And V sub X is the control voltage. Mu is the gain. The unit, yes. This is control voltage unit. This is voltage source is the unit. So the unit being V, V sub S is equal to mu times V sub X. So how about the current control voltage sources? Okay, same voltage supply, V sub S, I sub X is controlling current. Rho is the gain, was the unit, B and A. A is the control part, V is the voltage sources. So that was the shape of the diamond, plus and minus. Okay. All right. So how about dependent current sources? That is also VCCS. The other one CCCS. Okay. So VCCS is voltage control current sources. I sub S is the current supply. V sub S controlling voltage. R pi is the gain. So you need A over B. Okay. And the current sources is different from the voltage sources. The voltage sources plus minus, like this one. The current sources is like this one. So for this one, the voltage controlled the current sources. So this is the part, the alpha, the gain multiply the control something in here is like voltage control V sub X is the current sources. How about this one? The current control. The current control means so this Y, beta, the gain, the I sub X. That is also diamond and arrow. This is the direction, the shape of the current sources. So current control, current sources, I sub S is current supply. Definitely I sub X is controlling current. In here, there was Vx current controller controlling the voltage, but I sub X is the controlling the current. The beta is the gain, and whose unit is A over A. All right. So that is summarized in our circuit symbol for idea dependent sources. The first one is voltage sources because the V sub S, and mu is the gain, V sub X on the controlling voltage. We want to call this idea dependent voltage control voltage sources. The second one is again supply voltage dependent right there. And on the controlling current I sub X multiply rho time I sub X. So that was for source voltage. And then in here, the current sources, I sub S is equal to alpha times V sub X. V sub X is on the controlling voltage, alpha is gain, but that was source current, okay? The last one, the beta I sub X is equal to I sub S. The beta was gain for the current sources controlling the current I sub X. So that was the fourth side, okay? You have to memorize and the practice more familiar with to figure out the function shape or of each voltage and current dependent sources. All right, it's a really simple few questions to make it clear for the concept. First of all, if I sub delta is 15 milliamps, how much voltage does this dependent source supply? That was 100 times I sub delta, 100 times 15 milliamp. 100 times 15 milliamp, divided by 3, that was V sub S source voltage. This is the gain. This is the controlling current. Okay, so that was 1.5. The unit should be voltage. Okay, how about this one? The gain is 0.25, dependent sources. This shape is the current source, right? This is the current sources. Okay, so that unit is definitely the current source is A, the current, the controlling. So this is Y, then what the A. So that's the last one. How about the V sub X? V sub X for volt. This is the 80 volt. However, it cannot be calculated from the supply. Why? Because that was not for dependent voltage sources. This is dependent what? The current sources. So we cannot figure out V sub S for this case. Okay, don't be confusing. All right, so there is the still really simple yes and no questions. So that was for the circuit. That is the symmetrically the base on the A and B line. The left side, the right side, the same, the 10 volt. Okay, so two idea same, the identical but 10 voltage sources are connected into the pedal. The ideal voltage sources the imposed a fixed voltage across the terminal. Okay, and since both voltage sources have the same voltage 10 volt, there is no conflict between them. Okay, so that was the value. Okay, so for example, that was 10 volt. That's 1 is the 10 volt. Okay, so V sub R sub 1 is what? The 10 volt. So no no elements between the two parallel, the line, that should be the same. Okay. So how about this one? No, because that was the KCL. Maybe entering I sub A, leaving the I sub B should be the same. But that was not the same. Okay. So how about this one? This is the temple, A and B. That was the current, the ideal current sources. They connect in the series. So the current sources show the fixed current 5A through the circuit, while the ideal voltage sources, yes, 10 volt, maintain constant voltage across this terminal. So since they are in series, the conditions do not conflict of the circuit operation. So that was valid. Okay. All right, that was the simple question, interconnected sources. This is the circuit. This is the independent current sources, independent voltage sources. That was dependent, the voltage sources. This is the dependent, the idea, dependent current controlling voltage sources. Okay, so what value of V sub G is required for interconnection to be valid? So the question is, what is the V sub G? Okay, what is the V sub G? So step one in here, that was reverse direction. So I sub B right here, AM here. So I sub B is what? Minus AM. Okay. And that was plugged in here, minus AM over 4 minus 2M. Oh, I'm sorry, minus the 2 voltage. Why? Because that unit was the voltage, because that was the ideal dependent sources, the voltage sources. So this is minus the 2 voltage, and that was also minus the 2 volts. Are in parallel, they should be the same. So V sub G, that was minus 2 voltage. Okay. That is answer for the 2.1a. How about the B? For this value V sub G, find the power associated the AM. So let's say V is the equal to VI. That was for plus and minus. We learned before. This is going out, minus. Okay, minus. So now what is the I? Oh, I'm sorry. The what is the V? The VG minus 2 volt. What is the M? The AM. So that was for minus 16 plus the 16 watts. It was different. Oh, it's interesting. Plus, okay. So I sub B right there, AM, G, the AM. Oh, okay, that's right there. V sub G minus 2 volt. Yes. So that was for minus 2 times 8. It was minus 16 watts. Yes, minus 16 watts. I was being confused. Okay, that was the VI. For this case, we don't need it to the earlier the assign for the polarities first. Okay, P VI. So it depends on V and I value minus 2. So I was given, was calculated before. That was what we wanted to do. Okay. So we just discovered the power associated with AM. So it's the minus 60 watts. Okay, so the source is supplying or observing. Minus value, go side. Yes, that was the supplying. All right. So the last questions for today. For the circuit shown, what value of ARPA is required in order for the interconnection to be valid? So let's say, what is it? This is idea, voltage, control, current, source. Okay. All right. So what is for, so what are they looking for? So we needed to find the ARPA. Okay. That was the current source mean the unit is M. Okay. The reverse directions minus 15 amps. That is also the difference value. So that was ARPA minus 25 volt. This is the base of X right there. So ARPA is I over 3, 0.6. Okay. That was unit for A over B. Okay. B was the controlling part. That was the source part. Okay. So 0.6. So the next one, find the power associated the 25 sources. Okay. Here that was really simple. So P is equal to V and I. What is V? Okay. 25 volt. What is the I? 15 M. Okay. So that was 375 watts. Okay. 374 watts. So that is what we want to do.